Namaste. Welcome to our YouTube channel LKG Last Night Guru, where night starts from K and K stands for knowledge. So let us start with today's topic. Today's topic is breadth first search. This is called as BFS. Okay, it is BREADTH first search. What do you mean by this BFS? There is one more technique that is called as DFS that we will look at in our next video. BFS and DFS are graph traversal techniques. Okay, graph traversal techniques or graph searching techniques where we search or where we traverse through the nodes of the graph. Okay, for tree we have in order, pre-order, post-order. So there are different techniques. Especially for graph, we have two type of techniques, that is BFS and DFS. So in this video, we will see only BFS, that is breadth first search. Let us look at the example. So this is the example for breadth first search. So this is a cyclic graph where we have cycles and it is an unweighted graph. There is no weights. If there is weights also, it will not be taken into consideration. We are just traversing through the nodes of this graph. See, in BFS as well as DFS, we can take any node as a source. Okay, we can take any node as a source. Particularly, there will be no source given. But in exams, to reduce the work of invigilators, they might give the source. Okay, if source is not given, you can take any one of the node as a source. If source is given, start with that node. Okay, so for example, now the source is not given. I'll take source as 8. Okay, I'll take the source as 8. This is my source and I need to start traversing from this node. Okay, so what is the problem statement of this BFS? The problem statement of BFS is we need to visit all the nodes exactly once. Okay, we need to traverse along all the nodes exactly once. Okay, and the number of nodes or number of vertices here is 9. Correct, the number of vertices or nodes is 9 here, and there should be only 8 edges. There should be n minus 1 edges. N minus 1 edges. That is nothing but 9 minus 1. That is nothing but 8 edges. You should have 8 edges. So you will get 8 paths. Okay. So let us try to solve this graph using BFS using table. Okay. So I'll just draw the table. So the first column will be your source, from where you are starting your traversing. That will be your first column. Second column will be adjacent vertices. You can call them as adjacent vertices or also adjacent nodes. Okay, and your next will be visited. What are the visited nodes? And the last will be your path. You can call it as path or you can also call it as output of your BFS. Okay, see, what is the data structure that we use in BFS? Okay, the data structure we use to solve BFS is nothing but it is a queue. Okay, I'll write here only. The data structure which we are using is our queue, which follows first in, first out. Which follows first in, first out. Okay, this is called as FIFO method or first in, first out method. So with the help of this queue, we will be solving this BFS. You can add this queue column here itself, or else you can draw a separate queue. If you want, you can draw a separate queue. So let us solve this now. So the source is given as vertex 8 and here is the queue. And what is the length of the queue? The length of the queue is exactly equal to number of nodes in a graph. What is the total number of nodes in a graph? It is 9. So the length of the queue will also be equal to 9. Okay, very simple. So let us start solving this. See, the first table and the first value, it is already being given, that is source is equals to 8. Okay, what do you mean by adjacent vertices? Adjacent vertices are nothing but the neighboring vertices or the neighboring nodes which are next to that nodes. See, if you look at this 8, what are the neighboring nodes? It is 0 and 4. What are the adjacent vertices? It is 0 and 4. Correct? Now, what are the visited? See, 8 we have already visited. That is nothing but your source. We visit 0 also and we visit 4 also. What is the path? 8 to 0 and also from 8 to 4. See, in BFS, we will visit all the child nodes at once itself. Okay. Before moving to another node, we will finish or we will traverse all the child nodes of that node. Which are the child nodes? Same thing. If we consider 8, if we consider 8 as a parent node, what are the child nodes of 8? 0 and 4. See, if you want to move to the next node, first we need to traverse all the child nodes of that node. Okay. So we visited all the child nodes, that is 0 and 4. 8 has two child, 0 and 4. So we visit from 8 to 0 and also from 8 to 4. Okay. Same thing. See, the source was 8. We will update that in the queue. The source was 8. After that, we visited to 0 and also we visited to 4. Okay. See, now, is there any other adjacent nodes for 8? Is there any other adjacent nodes? No. Because there were only two adjacent nodes and we visited both of them. So now 8 can be removed from the queue. Okay. Now 8 can be removed from the queue. Which is the top of the queue now? 0. Right? 0 is the top of the queue. So 0 becomes my next source. Very important. Right? So if 0 becomes my next source, we are here now. What are the adjacents of 0? 8 is also an adjacent. See, 8 is also an adjacent. 1 is also adjacent node. 3 is also adjacent. 8, 1, 3. So in visited, this will be 8, 0, 4 are previously visited. What are the two new nodes that we are visiting? 1 and 3. Getting my point? Yes. See, now which is the source? Source was 0. From 0 we visited to two new vertices, that is 0 to 1 and also from 0 to 3. So this becomes our output. We have already covered 1, 2, 3, 4. We got 4 edges. Correct? How many edges we should get? We should get exactly 8 edges. Because how do I know that? Number of nodes is 9. When number of nodes is 9, the number of edges will be 8 only. Right? So we have visited all the adjacent vertices of 0. Okay? So we visited both 1 and 3. Right? So 1 and 3 has to be updated in the queue. And 0 has to be popped out. Correct? 0 has to be removed from the queue. Now which is the top of the queue? 4. 4 is the top of the queue. Okay. We come to 4. What are the adjacents of 4? 8 and 3. Correct? 8 and 3. See, the thing is 8 and 3 are already visited. Correct? 8 and 3 are already visited. So what is the problem statement of BFS is? We need to visit exactly once for all the nodes. So this will be as it is 8, 0, 4, 1, 3 itself, and there will be no any path. We are not going from 4 to anywhere because already for 3 we visited from 0. So no need to visit from 4 again. Correct? So there is no any addition to the queue. So 4 will be deleted. Which is the next top of the queue? 1. 1 is the top of the queue. Okay. So we come here. And what are the adjacents of 1? 0 and 7. Out of which 0 is already visited. The new node which we are visiting is 7. Correct? So in visited, it will be 8, 0, 4, 1, 3 and then 7. What will be the path? Yes, the path will be from 1 to 7. Getting my point? And 7 will be added to the queue. And 1 will be deleted from the queue. Which is the next top of the stack? Top of the queue. Top of the queue is 3. Correct? Top of the queue is 3. We come here. What are the adjacents of 3? 4, 0 and then 2. It is 4, 0 and then 2. Out of which 4 and 0 are already visited. What is the new node that we are visiting? We are visiting is 2. Correct? So this will be 8, 0, 4, 1, 3, 7 and then 2. From 3 to 2 we are visiting. And this 2 will be added to the queue here. And 3 will be deleted. Right? So which is my next top of the queue? 7. 7 is the top of the queue. Correct? So we come here. From 7, what are the adjacent to 7? 2 and 1. 2 and 1. But 2 and 1 are already visited. There is no any other nodes to visit. So this will be as it is. I am putting ditto here so that you can copy it on the same thing. And there will be no path. So 7 will be deleted from the queue. Right? Which is the next top of the queue? Top of the queue is 2. What are the adjacents of 2? 7, 3 and 5. 7, 3 and 5, out of which 7 and 3 are already visited, right? only thing remaining is 5. We are visiting 5 again. So this will be 8 0 4 1 3 7 2 and then 5. We are visiting a new node, that is 5. From where we are visiting? We are visiting from 2. So this will be 2 to 5. So next, so 5 will be added to the queue, correct? Now 2 will be deleted from the queue because we visited all the adjacent of 2, which is in the top of the queue. Top of the queue is 5. So 5 will be added as a source here. So which is the adjacents to 5? 2 and 6. Right? It is 2 and 6, out of which 2 is already visited. Which is the new node we are visiting? That is 6. So this will be 8 0 4 1 3 7 2 5 and then 6, and then this will be 5 to 6. Now, so 6 will be added to the queue here again. So 5 will be deleted. 6 will be my next new source, and then 5 is the only adjacent, and this becomes as it is, and there is no any path, right? And there is no any path. Now count the number of path we got. 1 2 3 4 5 6 7 8. We got 8 edges, right? We already know that this is the answer, right? So obviously 6 will be deleted from the queue. Once the queue is empty, we will stop our iteration. So these are our answer. These are our edges. So with the help of these edges, we need to draw the minimum cost spanning tree, or just spanning tree. Since the cost is not associated with the graph, we will just draw the spanning tree for this graph with the help of these edges. So let us draw the spanning tree for this graph. So the first one is from 8 we are visiting to 0, and also from 8 we are visiting to 4, correct? From 8 we are visiting to 0, and also from 8 we are visiting to 4. Next, from 0 we are visiting again 2 nodes, that is 1 and 3, correct? Yes. From 1 we are visiting node number 7. From 3 we are visiting to node number 2. And from 2 we are visiting to node number 5, and from 5 we are visiting to node number 6. This is the answer for BFS. See, one more thing is, it depends on the node which you are taking from the table. See, for example, from 8 first you can go to 0, or else you can go to 4, right? See, in Q I have taken 804, right? There is no compulsion that you need to take 804 only. You can take 840. You can visit in any order, correct? So it depends on the student who is solving this sum. So one student might get different answer, and another student might get another different answer. So it completely depends on how you have solved that. If your answer is correct, it's well and good, right? So this was all about BFS. So then you will get a spanning tree. How do you know that this is a spanning tree? Because the number of nodes is exactly equal to the number of nodes in the graph, and edges is 8. So n is equals to 9, and number of edges is equals to 8, and there is no cycles here. As you can see, there is no cycles involved. So this was all about BFS. So in the next video, we will see the depth first search for the same graph. Thank you.